In this lesson, we're still going to be dealing with parallel lines and a transversal. However, if you read the learning target, and please write it down as well, we're going to be using angle relationships to prove that lines are parallel. In the previous lessons, we were talking about parallel lines and that angles are congruent because the lines are parallel. Well, in this lesson, we're going to be saying if two lines are cut by a transversal so that the angles are congruent, then the lines are parallel. So we're actually going the opposite direction. If you see, all of our vocabulary here have the word converse. Okay, and so the converse is the opposite. So we're saying the opposite of what we were talking about before. We're kind of going backwards. And so when we look at the example problems, you'll see that we have to actually find out if the angles are congruent, then we can say the lines are parallel. Alright, so if we read through corresponding angles converse, it says if two lines are cut by a transversal so that the corresponding angles are congruent, then we can say that the lines are parallel. So we're not starting off with the lines being parallel, we're trying to prove that the lines are parallel. So let me just go ahead and draw a little picture here. We don't have any parallel markings on these lines. Okay, so the reason that we don't have any parallel markings on the lines is because we're trying to prove that the lines are parallel. So if I have an angle measure of 60 here, an angle measure of 60 here, then I say, okay, well, those corresponding angles are congruent, so now I know that these lines are parallel. Okay, so now I can put my the parallel markings on those lines. So that's kind of what the whole lesson is about, and we're still using the same angle pairs, but this time we're going to check and see if the lines are parallel. Alright, so alternate interior angles converse is saying the same thing. If we have two lines that are cut by a transversal so that the alternate interior angles are congruent, then we know the lines are parallel. So the important part is checking to see if those angles are congruent, and then you can say yes, those lines are parallel. So it works both ways. In our previous lesson, we were stating the angles are congruent if the lines are parallel. This time we're saying if the angles are congruent, then we know the lines are parallel. Alright, and so we're saying that for each of these different types of angle pairs. So alternate exterior angles, if the alternate exterior angles are congruent, then we can say the lines are parallel. Same thing for the consecutive interior angles. When we see that two lines are cut by a transversal, if the consecutive interior angles are supplementary, remember those are that's just the one angle pair that adds up to 180, then we know those lines are parallel. So let's just draw a picture here. If we have this angle, this set of lines, and we have, let's say, 120 and 60, okay, if those are the two measures of those angles, then we know that these two lines here are parallel because 120 plus 60 is, that doesn't really look like a triangle, sorry. Then 120 plus 60 is 180, therefore the lines are parallel. Okay, if those numbers don't add up to 180, then the lines are not parallel. Okay, let's take a look at example number 1. It says to apply the corresponding angles converse, and it says find the value of x that makes j parallel to k. Now, if we don't know what j and k are, then we need to figure that out. J is the name of this first line, K is the name of this second line, and remember this symbol here means parallel. Okay, so we need to find a value of x so that we can make J parallel to K. Alright, so that means that this corresponding angle has to be equal to this corresponding angle. Remember what the corresponding angles converse says. It says if two lines are cut by a transversal so that the corresponding angles are congruent, okay? So we have to make the two angles congruent by solving for x, and then we can say that those lines are parallel. Okay, so let's set this up. We're going to say 53 equals 7x plus 4. All right, and then let's read the hint. It says that lines J and K are parallel if the marked corresponding angles are congruent. All right, I think I stated that already. So I'm going to subtract 4 here because it doesn't have an x with it, and subtract 4 from the other side. I get 49 equals 7x. Okay, if I divide both sides by 7, then that means I have x equals 7. All right, so that's the value of x that would make this angle 53, which would make these two lines parallel to each other if both this angle and this angle are 53. Remember, corresponding angles are those angles that are in the same position. Okay, so you're going to try this type of problem on your own. Number 1 here says find the value of x that makes L parallel to M. Okay, again, 110 and this expression here need to be set equal because those are corresponding angles, and if they are congruent, then we know that lines L and M will be parallel. And in number 2 it says, is there enough information in the diagram to conclude that line G is parallel to line H? Okay, so this makes it does make you think a little bit, but please explain. Don't just write yes or no, but give a little bit more information and kind of work through your thinking in that in terms of the explanation. We have a couple of example problems to work through here. Show lines are parallel is what the example 2 says. Use the diagram at the right, and we need to find the value of x that makes line A, parallel to line B. Notice that there are no parallel markings on the lines right now, and these two angles are actually consecutive interior angles. Okay, so these two angles have to equal 180, and if those two angles equal 180, then we know that lines A and B are parallel. So let's set up an equation that's going to be 62 plus 5x minus 2 equals 180. Okay, so I'm going to combine the things on the left that I can combine. This negative 2 and this 62 can be combined to 60 plus 5x equals 180. And then I'm going to subtract 60 from both sides because those are terms that have no x. That cancels. 5x equals 120. And my answer for x here is going to be 24. So if x is 24, that makes this angle here exactly what it should be so that the two angles add up to 180 degrees. In this last example, it's asking us to find the value of y that makes A parallel to C. So now we're looking at A and C. Okay, if we recall from the first page of our notes, transitive property says if two lines are parallel to the same line, then they are parallel to each other. That doesn't exactly directly apply here, but I want you to think about the fact that if we do not have this line here, okay, if this line is completely gone, then we really do still have two lines there that we have this angle here, which is 62 degrees, and this angle down here, which is an alternate interior angle. Okay, so we're looking at the two lines A and C. We're ignoring that line B for right now. And we need to find the value of y that makes those two angles congruent so that the two lines A and C are parallel. Remember, if the two angles are congruent, then the lines are parallel. So I'm going to set up an equation 62 equals 7y plus 6 because these two angles are alternate interior. Remember, they're inside the parallel lines but opposite sides of the transversal. And if they are equal or congruent, then I know that my lines are parallel. So we're going to subtract 6 from both sides. I'm ending up with 56 here equals 7y. If I divide by 7, then y is equal to 8. Okay? Now on these on your own practice problems down here, I would like you to do numbers 3, 4, and 5, and just recall that you're finding the measure or the size of x to make the angles equal. But in number 5, you don't want them to be equal because these are CIA. Remember, these two angles have to equal 180. So when you set up your equation, make sure that those two are added together and set equal to 180. That's how you're going to find x. So they're basically saying what value of x is going to make it such that P is parallel to Q in each of these problems. All right, so write some questions down if you're not quite understanding, and I'll be happy to answer those questions in class.